You know how to use PowerShell remoting over HTTP, but in many environments, you know that's simply not enough. Today, we're setting up PowerShell remoting over HTTPS with encryption, certificates, and proper authentication. It sounds complicated, but I will guide you step by step, and I'll show you all the things that trip most of the people. In this video, we're finally going to answer the question, is PowerShell remoting actually secure? And in addition to that, we also answer the question, what is the difference between PowerShell remoting over HTTP and over HTTPS? Why do we have two different protocols? I'll show you also all the theory that is behind all of these protocols. So you won't only learn how to set up PowerShell remoting over HTTPS, but you will also understand the reasons behind it. We will cover all the commandments that you need to know to use PowerShell remoting over if possible. I will show you how to configure PowerShell remoting over HTTPS with self-signed certificate, which is perfect for your own lab environment. But don't be scared. We also see how to do things properly and set HTTPS up with certificates which are delivered by a PKI. I will also show you tips and tricks and the most common errors and how to avoid them. My name is Stefan and welcome to my basement. I'm a former PowerShell MVP with over 15 years of experience. I've been automating Windows and Linux environment for quite some time. I'm a PowerShell author, a Devops engineer, and I've been speaking in the biggest conferences related to PowerShell in Europe. On this channel, I teach Linux and Windows admins how to code. Last time we clarified how PowerShell remoting over HTTP works. Today, we're gonna tackle PowerShell over HTTPS. Are you ready? So let's start. Is PowerShell remoting actually secure? And I'm gonna cut straight to it. Yes, it is. Okay, but why do we have HTTPS then if WinRM over HTTP, so the basic version, is already secure? Well, that's a very good question, and I'm glad you asked it. Let's have a look and answer this question right now. Let's have a look at what WinRM actually is. We know that WinRM is Microsoft's implementation of the WSMan standard. It is used for managing and monitoring devices remotely and relies on a client-server-based model. We already know that WinRM, or actually WSMan, implements SOAP, the protocol that tells, hey, we need to transfer our messages in XML format. And so what we didn't know yet, or at least what I did not tell you guys yet, is how this XML is being transferred over the network. And that is being done using protocol like HTTP or HTTPS. WSMan will ensure the security of the message being transmitted by encrypting the message prior to sending it over the network. Then the next logical question would be, how does it encrypt it? The logical answer would be, it depends. The message level encryption is defined by the initial authentication protocol that is being used when they establish this connection. Different authentication methods provide various levels of encryption. In a nutshell, there are 4 encryption levels that are important to us. 1, using Kerberos, aka being part of an Active Directory domain. When you're part of an Active Directory domain, the encryption is defined by the E-type in the TGS ticket, which is commonly AES 256. When using NTLM, aka being in a workgroup, or when using an IP address to create the connection, it will use RC4 cipher with an 128-bit key. So although this is encryption, it is known to be a weak encryption. So if you can avoid it. And for CredSSP, encryption is defined by TLS cipher suite, which is negotiated during the handshake when the HTTP or HTTPS connection is established. And then there's basic authentication. When using basic authentication, you're basically disabling the message encryption of every SOAP message, and you're just sending data in clear text. If you want to do that, maybe for test reason, or maybe you have other reasons to do it, Microsoft doesn't make it easy for you to do. Using basic authentication in a production environment makes probably no sense, but you can still do it. So to sum it up, is WinRM secure? Yes, it is. Your packages, when they will be sent over the network, They will never be unencrypted, except if you enable the basic authentication method. Please don't do that in production. So yes, packages will never be sent unencrypted over the network. The WSMan will always encrypt the packages before sending them over the network. And the level of encryption that this package has depends on all those two systems have authenticated. So one of those four values over here. So in a nutshell, if you are an Active Directory domain and using WinRM over HTTP, the regular one, this is way more than enough. As soon as you need to communicate outside of the boundaries of your Active Directory domain or in between workgroups, then HTTPS becomes the logical next step for your production and secure communication scenario. When using PowerShell remoting with HTTPS, the individual messages that will be sent over the network will still be encrypted. But in addition to that, we're going to have the HTTPS tunnel that's going to be created, which will ensure that the transport layer is completely encrypted. And in that transport layer, the encrypted message will travel. And in addition to that, in order to use HTTPS, you need to have a certificate. And this certificate must be delivered by an authority system that you trust. And in the end, it verifies the identity of your client and your server, and it proves, the certificate proves that the machine you're talking to is really the machine that you are talking to, and not a man in the middle. So enabling HTTPS will also help you prevent man-in-the-middle attacks. Hey, if you're not subscribed yet, it would mean the world to me if you can hit the like and the subscribe button. This really shows actually the interest you have for the channel, and it pushed me really to make more content. So in order to configure WinRM to use HTTPS, we need to create a new listener. So first, let's list the listeners that are currently available to us in this specific machine. So we can see here that we have one listener right now. It is enabled and its transport mechanism is HTTP. And by the way, I will put all the commands I type with code examples down in the link in the description below. So in order to use WinRM over HTTPS, we need to have a certificate. And we can create a certificate using two ways. First would be the bad way, which is a self-signed certificate. And then the second, the good way, would be to ask for a certificate at your certificate authority, so at your PKI, or even buy one online. So in order to create a new self-signed certificate, we can just use the new self-signed certificate commandlet. In order to create a new listener using the HTTPS transport mechanism, we can use WinRM quick config and specify the transport to be HTTPS. It will detect automatically an existing certificate in your local certificate store. But as you can see right here, this will not work. Why did it not work with WinRM quick config transport HTTPS? Well, the solution is in the error message. Cannot create WinRM listener because this machine does not have an appropriate certificate. And why is that? It mentioned it here. A certificate must have a CN matching the host name. It must be appropriate for server authentication and not expired. And it cannot be self-signed. And this is exactly what we're trying to do. So, Stefan, that doesn't even work, your solution. There's another way to do this. So does that mean we cannot implement a self-signed certificate for HTTPS? No, we can. And so why do we have this message in the first place? Well, for security reasons. Everybody can create a self-signed certificate. It is a best practice to go request a certificate at your PKI, which we'll cover right after this part. But if you're doing this in a lab environment, just for testing purposes, this is fine. So we need to identify the thumbprint of our certificate, and then we can go ahead and create the listener using new item. And we will create the listener in the WSMan store, and we will specify the thumbprint of our self-signed certificate as certificate thumbprint parameter. And if we go ahead and list the current available WinRM listeners, we can see that we have now two listeners, the HTTP and the HTTPS one. Notice as well that we did not configure anything. The HTTP listener will listen on port 5985, and the HTTPS listener, which we just created, will be listening on port 5986. If you remember earlier when we configured PowerShell remoting using quick config for the HTTP scenario, so basically WinRM out of the box, at that moment, it created for us the firewall exception. In this case here, HTTPS will not do that for us. So we have to create it ourselves. So this is pretty straightforward. We just go ahead, create a new firewall exception. We give it a useful name. The firewall exception must be for TCP on port 5986. Of course, we want to allow the connection. We can specify which network we want it on. Here we got to select it all. And that's it. If we go have a look now, we can see that our new firewall exception is created and available. So if we want to go one step further, we can go ahead and actually remove the HTTP listener. This would be perfect for systems that need to be highly protected, highly isolated, or for example, banking systems or anything that is important in your field. And we can do that by simply deleting the HTTP listener on the WSMan provider using the command that I'm showing right now. If we list the listeners right now, we can see we have only the HTTPS listener that is available. So now let's go ahead and test this connection. Hey, have you done it yet? Did you subscribe? If not, the button is right there. So this system is part of an Active Directory domain. I'm just fetching the credentials. And so I use new PS session in order to open a session to my remote machine. Here we have it again, another error message. And the error message doesn't go blah, blah, blah. Read the message carefully. Again, it says it right there. The SSL certificate is signed by an unknown certificate authority. In other words, this means Windows does not trust this certificate, and it will prohibit you to use it for more security. You can still use it if you want, but you need to go ahead and tell them, hey, it's all fine. I'm actually okay with using a self-signed certificate. And so here we create a new option using new PS session option, and we specified the dash skip CA check, which basically does what it says. It will avoid the check for the CA. And now we attach this option to our previous command and we execute it again. You will see that it creates the connection now to the remote machine. We can see that the session is now open, and we can enter into our session using enter PS session and execute some commands, and we can see here that we are on the server Win103. On this machine, we can also list the open TCP connections, and if we have a closer look at this, we can see that the connection has been done over the port 5986, which is our HTTPS listener port. Now that we have seen how to use PowerShell remoting using HTTPS with a self-signed certificate, let me show you how easy it is to configure PowerShell remoting using HTTPS with a valid certificate, which has been provided by your PKI. So in my lab environment, I do have a PKI, and we are going to go and request a new certificate. So this certificate is not going to be self-signed. It's going to be signed by my public key infrastructure. For that, we open the local certificate store. We go to personal certificates, all task, and request a new certificate. Here we select Active Directory enrollment policy, click next. Out of the list of types, we select computer. Here, in this case, that's the only type available to us. So we just go ahead and select computer. And that was it. Now we can see that we have a new certificate in our store, which has been issued to this specific server. On this server, if we list the listeners that are currently present, we have only an HTTP listener. And now using WinRM quick config transport HTTPS, and will ask us to confirm that we really want to create the HTTPS listener. We say yes, and voila, that was it. Easy, right? So let's list the listeners. Let's be sure that it created the HTTPS listener, and it actually did. We have the HTTP listener and the HTTPS. Now let's go ahead and try this connection. See? So right now I'm going to try to use the dash use SSL parameter, but I'm using an IP address. It will refuse to establish the connection. But why? So now you know it. Don't blah the error message. Read it carefully. It says here that the default authentication mechanism may be used under the following conditions: if the transport is HTTPS or the destination is in the trusted host, and if explicit credentials are being passed. And by the way, we're going to talk a little bit more about trusted host in just a few minutes. So if we're using now the FQDN, the machine we're trying to reach, then the connection is actually established. Go ahead and connect to the session and we can list the current open TCP connections. We can see that the TCP connections on port 5986 are currently open. Bonus, because I'm a friendly person, partial remoting requires local administration privileges in order to be able to create a remote connection. If you do not want to provide local administrator privileges, then you can actually create your own remote access group, maybe one for all the machines and specific ones for specific machines, and deploy these groups using group policies. What you need to do is simply add that group in the remote management users local group, and you can then remove that specific account from the local administrators group. Exactly what I've done here. Thank you. You're welcome. So that was it. We've seen how to configure partial remoting using HTTPS with a self-signed certificate and using a certificate provided by your local PKI. And it was easy, huh? I told you so. With WinRM over HTTPS working in your environment, you're ahead of most admins out there. You're almost there with knowing everything about partial remoting. You want to see how the modern cross-platform way of remoting actually works? Explain everything about partial remoting over OpenSSH in this video right here.